Emergency button. If the user taps the emergency button or indicates through voice using the microphone that they are having an emergency, TMU-IRES automatically connects to emergency services. The application immediately gathers data already on the phone. This includes user information such as their name or medical conditions they've chosen to store, for example, sharing that the user is diabetic. It also collects GPS location from the browser or operating system, and a timestamp which will be automatically logged. The moment the user triggers this, two things happen at the same time. First, a native phone call is triggered. This simply starts a regular 911 call or a region-specific dispatch number. It behaves the way a normal emergency call would. Second, a parallel cloud event is sent to the TMU backend. This request sends all the user's information, the timestamp, location, device type, network status, and other relevant data to the TMU server. The server forwards the information to the emergency services dashboard. The emergency service running the system immediately receives an event showing that this person from this number has indicated an emergency and sent all of this information. Even if the caller cannot speak or loses consciousness, EMS already has their location and medical data without needing to ask. Report incident. The Report Incident button is not for a personal emergency. It is for making a report about something that is or has happened. If the user taps Report Incident or uses a voice command to indicate the same, an incident report object is instantly created. An incident report can also be submitted through a dedicated WhatsApp number in the same manner. The user is then prompted to take a picture or video of the situation. A picture or video is the base requirement to submit a report. However, users have the option to add more context, such as multiple images, videos, audio, or text. The TMU backend receives this information. Our AI services analyze the content to classify the type of incident, for example, traffic accident, fire, hazard, and provide more readable location information. It also generates a structured incident report, so dispatchers can clearly understand and organize what has been sent. Before the report is sent, the user must verify the AI-generated information is accurate. They can correct anything that is not. Once confirmed, the data is sent to the Emergency Services Dashboard. Emergency Services Dashboard. The most basic version of the Emergency Services Dashboard is a TMU group chat interface that has been labelled and organised appropriately. It can be structured by alerts for different areas, incident type, or however the agency divides reports. When a user submits a report, it appears as a message with the location, detected situation, recommendations, and a confidence score. For example, 2 vehicles detected in a freeway accident, 91% confidence. Dispatchers can manage the incident, marking that units have been dispatched, adding notes, or indicating whether someone is already handling it. Multiple dispatchers can view and coordinate inside the same chat. Drone operator workflow. The drone operator workflow is managed through a TeleMeetUp session. Drone operators, or anyone viewing the drone feeds, join a TMU call. The drones live stream their video to the session. Periodically, frames from the video are processed by AI on the back end. Depending on the mission, the system may look for people, vehicles, smoke, tents, fallen objects, or movement patterns. If nothing is detected, the system continues monitoring. If something is detected, the API returns an annotated image. These images can be saved into whiteboard instances. Since we can have many whiteboards with different names, they can be organized however needed. For example, in a mountain search and rescue scenario, every time the AI thinks it sees a tent, that frame can be logged permanently. Viewers can make notes on or review the images as needed at any time. A notification also appears in the chat stating what has been spotted and which whiteboard to check. AI-enabled autonomy. Now let's talk about autonomy. AI allows the system to work with both structured workflows and AI-enabled workflows. The goal is not to pre-structure every situation. Instead, the AI draws from the knowledge and information in the system to take intelligent actions within guardrails. There are understandable concerns. For example, what happens if the AI makes a mistake? Could it cause more problems? That's why the system keeps human oversight where it matters most. For example, the AI can classify incidents, assign urgency scores, summarize situations, and identify what's happening in images. But it does not automatically dispatch units or send responders on its own unless an organization specifically enables that behavior. Users still verify reports before sending them. Dispatchers still control deployment. AI accelerates and enhances the process, but it doesn't replace human judgment in critical decisions. Emergency situations are highly dynamic. Things can change moment to moment. You may have multiple parties, multiple locations, and multiple units all involved simultaneously. Our system enables all interactions to be captured within a single real-time session. With proper implementation, everyone involved, the callers, dispatchers, drone operators and responders, can contribute to the assessment and response in real time. For example, imagine that suddenly, during response operations, there's an explosion due to an unseen gas leak. Everything becomes chaotic. In cases like that, real-time interaction and updated situational awareness are critical. That's what this system is designed to provide. Continuous real-time communication and assessment to support the best possible outcomes in rapidly changing emergencies.